Hello everyone. After the first question, this was second question. And if you carefully see, this question is totally different from the question number one. Here, they have given that the function fx, which is basically x square minus 1 by x cube minus 1, where x cannot be 0. And the interesting part is, they told us that the fx is continuous at x equals to 1. That means, given that, or we can write, since fx is continuous, fx is continuous, okay, continuous, okay. Since fx is continuous at x equals to 1, so what we have observed till now, that means the function f of 1 is same as limit x tends to 1 plus fx, limit tends to 1 minus fx. But these two can also be written as, that means the existence of limit is there, na? So you can write it as limit x tends to 1 fx. Okay. So since our function is continuous at x equals to 1, so our f of 1 is same as whatever the value of the function, okay, limiting value of the function when x is approaching towards 1. So let us find this limit, and this is going to be our f of 1. That means the value of the function fx at equals to 1. So the value of the function, that is fx at x equals to 1, is basically our f of 1, and which is nothing but limit x tends to 1 fx, and fx is given to us, which is x square minus 1 x cube minus 1. So here see, if you put the value of 1, we will get 0 by 0. So we can't do the limit here. But we can apply the standard some formulas of limit. But if you factors also, then also you can solve it. Like it is a square minus b square. So it is a minus b into a plus b. And this is going to be a minus b, a square plus ab plus b square. So we can cancel out x minus 1. Why? Because the reason is x is tends to 1 and x is not exactly 1. If x is 1, then the whole fraction is going to be the undefined. 0 by 0 is impossible. So you can write it as x tends to 1, x plus 1 by x square plus x plus 1. Now you can easily put the value of 1 because it is possible, or there is not 0 by 0 infinity by infinity form. So if you put, it will be 1 by 1, 1 plus 1, sorry, then 1 square plus 1, that is 2 by 3. That means the f of 1 is 2 by 3, which is our required answer. Okay. So move to the question number 3. This is also interesting part, but here the beautiful part is you have to expand the function which is given. So see, let me give you an idea in mod x, modulus of x, or absolute value of x. Basically, it is going to be are going to give you two values. It will give you x whenever x is greater than 0. It is going to be minus x when x is less than 0. You can take some example also, like see, if you take minus 2, then you tell me it will give you a non-negative integer, no? But if you see, this exactly giving you the negative of the whatever the x. That means whenever the value of x is negative, this one, then it is going to be u minus x, which is your answer. But if it is positive x, then it is exactly going to give you the x. So that's why I've written if the x is greater than 0, it is a positive quantity. So the absolute value of x is going to be x, and if the x is negative, then it is going to be the negative of x. Whereas one thing is missing here. Sometimes we include it here. If it is 0, then it is going to be 0. So you can put here also equal to, or some people write it other way also. Okay. So this is the exact definition of modulus of x. So taking inspiration from this concept, we have taken that mod x by x is basically when x not equals to 0. That means it could be the greater than 0 or less than 0. And it is 1 if it is x equals to 0. So expanding the function, it is positive x by positive x if x is greater than 0. Because we know mod x is x when x greater than 0. And mod x is minus x if x less than 0. And 1 is also already given, x equals to 0. So in next line, it is going to give you x by 1 means 1, x by x means 1, greater than 0. It is minus 1 and x less than 0. It is 1 and x equals to 0. Okay. So depending on these three values, we will check whether the given fx function is continuous. It is not continuous. We have to show it is not continuous. Okay. So let us find the left hand limit and right hand limit in that x equals to 0 point. Okay. So if you find limit x equals to 0 plus fx, you can write here to check continuity on x equals to 0. Okay. So we are first trying to find the value of limiting value when x is approaching 0 but little bit greater than 0. So see, it refers the greater than 0. No? So for greater than 0, the fx, the value of fx is 1. So we are putting here 1. So it will be 1. See, if you find limit of x tends to 1 minus fx, it is really going to give you, because sorry, not 1 minus, 0 minus, less than 0. So less than 0 is going to give you minus 1. So it is minus 1. So clearly these two values are not equal. We know the function is said to be continuous if that left hand limit, right hand limit, and the functional value at x equals to 1, sorry, x equals to 0, all are equal. Since limit x tends to 0 plus fx is not equals to limit x tends to 0 minus fx, hence fx is not continuous at x equals to 0 proved. Okay. Going to question number 4. So here also that I have given that the function is continuous at x equals to 0. And now we have to find whether, sorry, the value of the key. So since fx is continuous at x equals to 0, so we can easily say that the f of 0 is same as limit x tends to 0. Since both left hand limit and right hand limit will exist, so we can write it as limit x tends to 0 fx. Okay. So now try to put the value of f of 0. See, f of 0 is nothing but the value of fx when x equals to 0. So when x equals to 0, the value of fx is nothing but k. And here we have to calculate the limiting value of fx, that is 10 3x by 4x. So k is nothing but, now the interesting part is there. We have standard formula for limit, which is 10 x by x. So if you make it like 10 3x by 3x, you have to multiply it by 3 by 4 to make it same. But now also you can't put the limiting value. You have to see the value of this will be 1 if 3x tends to 0. Whether it is true? Yes, because since x is tends to 0, therefore if you multiply, or you can say similarly 3x will also be tends to 0. So for this reason I have written x tends to 0 can also be written as 3x tends to 0. And this part can be written as 10 3x by 3x into 3 by 4. Okay. So as we know that this part is going to give me the value as 1. So the next line can be written as k equals to 1 into 3 by 4. You should write as limit x tends to 0, 10x by x is 1. Okay. So the value of k becomes 3 by 4. Next. So in question number 5, we have to find the value of alpha. Similar question. When our fx is continuous at x equals to 1. So see, fx is continuous at x equals to 1. So similar thing we can write, since fx is continuous at x equals to 1, then limit x tends to 1 plus fx, limit x tends to 1 minus fx, and f of 1 all are same. Or including these both, we can also write limit x tends to 1 fx is same as whatever the value of f of 1. Okay. So now we'll separately find whatever the value of this limit. Okay. X equals to 1. So since it is continuous, we will also find the value of f of 1 and then so put it as 1 and try to find limit x tends to 1 fx. So limit x tends to 1 fx. So for fx, see, it is x tends to 1. That means x is tending to 1, approaching to 1, but although it is not 1. Okay. So, or I would say it will be more logical if you take these two. Okay. So let me solve using these two. Limit x tends to 1 minus fx and f of 1. Okay. So see, if you replace the concept of 1 minus here, it is basically referring you that the value of x is approaching to 1 but less than 1. So it is give you x square by 2. It is less than 1 approaching to 1. So x square by 2. Sorry, here you have no problem. You can easily put the value. Okay. So 1 square by 2, which is nothing but 1 by 2. But see, now you should calculate f of 1. F of 1 is nothing but the value of the function at x equals to 1. Okay. So for x equals to 1, the function is going to give you x square by 2 only. That means 1 square by 2, 1 by 2. But from here you can't find the value of alpha. That's why we need to calculate limit x tends to 1 plus fx as well. So see, for the case of x tends to 1 plus, it is basically the value of x is approaching to x but more than 1. So more than 1, it will be 2x square minus 3x plus alpha. So we are adding, it will be x tends to 1 and this side 2x square minus 3x plus alpha. Okay. Now if you put the value of 1, no issue will be there. So you can easily put 2 into 1 square minus 3 into 1 plus alpha. 2 minus 3 plus alpha, it is nothing but minus 1 plus alpha. Since the function is continuous, then all the values should be equal. So you can write, hence, minus 1 plus alpha should be equals to half also. All the values are equal. Then alpha is nothing but 1 plus half, which is given 2. Okay. Bring to the question number 6, which is also same. And most probably the important question. So here also we have to find the value of a whenever the function is continuous at fx x equals to 1. So since fx is continuous, which point? At x equals to 1, then we can say limiting value of x tends to 1 minus fx is same as limiting value of x tends to 1 plus fx. Okay. So 1 minus fx means if it will be x tends to 1, it is less than 1 but close to 1. So it will be x plus 1. And this side it is greater than 1 but close to 1. So it will be 3 minus ax square. You can easily put these two values. In this side it will be 1 plus 1, and this side if you put the value of x, 3 minus a into 1 square. It will be 2, it will be 3 minus a. So see, a will be 3 minus 2. Therefore, a equals to 1. Easiest one. Okay. So, moving to question number 7. So, in question that told us to check whether the function is continuous or not. So, we'll write to check continuity at x equals to 0. We have to find 3, na? Left hand limit, right hand limit, and the value of fx at x equals to 0, that is f of 0. So, limit x tends to 0 minus, since we have to check the continuity at x equals to 0. So 0 minus fx. So limit x tends to 0. It is less than 0. Okay. But close to 0. So it is going to be sine of 3x by 2x. To calculate the, you can put the value, na? It will be undefined. So you have to use the standard formula for limit. So this side it should be sine x by x. So we are making it sine x by x. And it should be 2, 3 by 2. Okay. Because if you cancel it, you will get the same value. But now also you can't put the value. You have to, it should be 3x tends to 0. It will be 3x tends to 0. Since x tends to 0, therefore 3x tends to 0. So now if you write sine 3x by 3x, and this side 3 by 2, see the value of whole is will be 1 into 3 by 2, and ultimately it is giving you 3 by 2. Okay. So I have to check it now. Okay, fine. Just find the value of RHL, or you can easily find the f of 0 also. If you find f of 0 here, the question will be more easier, because if f of 0 is nothing but the value of fx at x equals to 0. Okay, so f of 0 is nothing but 2 by 3. So see, to check continuity, that f of 0 and left hand limit, right hand limit all should be equal, but these two are not equal, na? So we can easily say the function is not continuous. So I will write here, since limit x tends to 0 minus fx is not equal to f of 0. Hence, see, you can find the right hand limit also, you will get not equal. But since calculating one lesser is sufficient, that's why I'm not doing that one. Hence, fx is not continuous at x equals to 0. Okay. Moving to question number 8. Here the function is given x, phi x. Okay. And we have to show that limit x tends to 0, phi x is equals to 2. Okay. That means there is existence, but we have to show it. Okay. So first we have to check whether it is possible or not. Okay. So to check continuity, some people do not check, but I will say you should check whether the function will be continuous or not. To check continuity at x equals to 0. How? Because x equals to 0 is there. So we have to calculate limit x tends to 0 plus. So limit x tends to 0 plus, it will be x tends to 0. For 0 plus, it will give you e to the power 2x plus 1. If you put 0, then it will e to the power 0 plus 1, which is nothing but 1 plus 1, it is 2. Similarly, limit x tends to 0 minus fx. For 0 minus fx, it is 0. Oh, sorry, it will be 5x. So it is less than 0. So 1 plus cos 2x. Now if you put 1 plus cos 0 is 1, is 2. Since these two are equal, hence phi x is continuous at x equals to 0. And you have already calculated, na? Limit x tends to 0, phi x is 2. Both are 2. Proved. Okay. Moving to question number 9. So now you have to check the given function whether it is continuous or not at x equals to 0 as well as x equals to 2. So to check, fx is continuous at x equals to 0. The first part. Okay. First we are checking at x equals to 0, then we will do it for x equals to 2. So left hand limit, that is limit x tends to 0 minus fx. This limit x tends to 0. So 0 minus, it should be less than 0, approaching to 0. So it is going to give you 2x plus 6. Put the value of x, 6. Similarly, find RHL is limit x tends to 0 plus fx. So limit x tends to 0 and fx is nothing but 0 plus greater than 0 close to 6. Now find the value of f of 0, that is value of fx at x equals to 0. So whenever x equals to 0, it is 2x plus 6. So 2 into 0 plus 6, it is 6. Since all are equal, since limit x tends to 0 plus fx is same as limit x tends to 0 minus fx and f of 0. So at x equals to 1, fx is continuous. Okay. Now we will do the same for x equals to 2. So to check fx is continuous at x equals to 2 or not, first we are finding left hand limit x tends to 2 minus fx. So limit x tends to 2 and then the value of fx, okay, it will be less than 2 plus close to 2, it will be 6, say the middle one, okay, so it is going to give you 6. Then right hand limit is going to give you 2 plus fx, limit x tends to 2 which is greater than 2, okay, so 2x minus 6. If you put the value is nothing but 4 minus 6 minus 2. Wow. These two are not equal. Since these two are not equal, so we will say the function is not continuous. Hence fx is not continuous at x equals to 2. Since these two are not equal. We will do the next part in another